Hi everyone. Today we are going to be looking at index or exponential function. We're going to be solving series of examples right here. In index function, one thing you need to know is that the unknown can be the power of a number, or it can also be the base. We're going to be seeing a lot of examples right here for you to understand what we are talking about. Let's look at this first question that says we should solve the equation 3 raised to the power of x equals to 27. In this case, you are trying to find x. You want to get x, okay? Now, if you look at this, like I said, that in index function, the unknown can be the power. So if you look at this right now, the unknown is x. It is the power of 3. In some other examples we are going to also be looking at, this unknown can be the base, okay? But in this case, this unknown is the power. We are trying to find x. Now, in this case, what are you going to do? What you need to do is to try to see if you can express this number right here to have a base that will be equal to this base right here. The base here is 3. This is 27. Can I express 27 to have a base of 3? The answer is yes, because 27 is the same thing as 3 raised to power 3. Okay? So that means this can be rewritten as 3 raised to the power of x equals to, instead of writing 27, I can have 3 raised to the power of 3. Very good, very good. So we've been able to express 27 as a base of 3, which is 3 raised to the power of 3. Okay? Now, since these bases are equal, they are equal now, right? You have 3 raised to the power x, 3 raised to the power 3. So now you have the same base, 3 and 3. So because you have that, you can then equate the powers. That means x now equals to this 3 right here. So now x equals to 3. That is your final answer. Okay? Take note of what we did again. This is 3 raised to the power of x equals to 27. What we did was to express 27 as a base of 3. 27 is the same thing as 3 raised to the power of 3. Okay? Now, since you have the same base right here and right here, all you have to do is just to equate the powers. X equals to 3. Okay? Let us take a look at another example right here for you guys to better understand this concept. Let us take a look at this. 2 raised to the power of x equals to 8. You want to solve this equation, okay? Now, if you take a look at this, this is 2 raised to the power of x. This is 8. Can I express 8 to have a base of 2? Express 8 as a base of 2. Yes, I can. 8 can be taken as 2 raised to the power of 3. In this case, your knowledge of multiplication table is very needed right here. So that means this 8 can be expressed as 2 raised to the power of 3. Very good, guys. Then I can bring down this one, 2 raised to the power of x. Okay? Now, if you take note, now we have the same base right here. We have the same base right here, okay? Now, because we have the same base, that means my power can be equal to each other. That means the powers are x equal to what? 3. Because the powers are x and 3, now they can be equal to each other. X equals to 3. That means I've been able to find the value of my x to be equal to 3. Very good. Let's look at some other examples to better understand these concepts. Example 3. What about if we have this 4 raised to the power of x equals to 8? You want to solve this problem set, okay? Now, if you take a look at this, the unknown is this guy right here, that's x, okay? Now, this is 8. Can you express 8 as a base of 4? No, you cannot do that. But if you look at this problem set very well, you realize you can express 4 as a base of 2. You can also express 8 as a base of 2. Take note, what you're trying to do basically is you want your right hand side and your left hand side to have the same base, which was what we had in this case. If you take note, in this first question, we had 3 and 3. These are the bases. We had 2 and 2. They are the bases, right? But in the case of this third example, we do not have the same base right here. This is 4 and this is 8. But we can make them to have the same base. How do we do that? 4 right here is the same thing as 2 raised to power 2. I hope you agree with that. Then you also have x. So I will bring x right here equals to 8 is the same thing as 2 raised to the power of 3. Okay, very good, guys, very good. Now, if you remember your law of indices, this 2 is raised to the power of 2, which is also still raised to the power of x. So now I can open up by multiplying the powers. 2 times x is 2x. That means I will have 2 raised to the power of 2x. Very good. Equals to 2 raised to the power of 3 right here. Okay, very good, very good. This is interesting. Now, if you take a look at these, now we have the same base. We have the same base. We have the same base. 2 is the base right here. Okay, you also have 2 as the base right here. Because you have the same base, what would you do? You would bring down, you will equate the powers. Now I can equate the powers. 2x equals to 3. Very good, guys, very good. Now, since I have 2x to be equal to 3 and I'm trying to find x, what would you do? You would divide both sides. Okay, you divide both sides by 2 because you are trying to find x. Okay, so that will be 2x over 2 equals to 3 over 2. Very good. Interesting. So that means in that case I can have 2 to cancel 2 right here, then it remains x equals to 3 over 2. Very good. And 3 over 2 convert to mixed fraction is going to be 2 in 3 is 1, remaining 1 over 2. So my final answer is x equals to 1, whole number 1 over 2. That is my final answer. Very easy, guys, very easy, guys. I hope you understand this concept. I will encourage you to go over the video again, go over the examples, for you to better understand, to ensure that you understand what we are talking about right here. Let's look at one more example here. What about if I have x squared equals to 4? X squared equals to 4. You have been asked to solve this problem set. Okay, if you remember what we said as for index notation, index function, we said that the unknown can be the power, just like this one. The unknown can be the power, like that one. Like also question 1, the unknown is the power, and question 2, the unknown is the power. Question 3, the unknown is the power, right? But in question 4, the unknown is the base. The unknown is the base. Okay, now in this case, if your unknown is the base, what you need to do is try to express these parts to have the same power as this right hand side. Okay, and that should be pretty easy right now, guys. If you take a look at this, 4 can be taken as 2 raised to the power of 2. You will agree with me that 4 is 2 raised to the power of 2. And then you also have x squared right here. Now if you take note, you will realize right now that the power are the same, 2 and 2. Because the powers are the same, what you need to do is to equate the bases. X equals to 2. X equals to 2. That is your final answer. You will take note that when we did question 1, 2, and 3, it was we had the bases to be equal to each other, because the bases were equal to each other, or they were the same rather, because the bases were the same. What we did was to equate the powers. 2x equals to 3, right? But in the case of this one, the power are the same, 2 and 2. Because the powers are the same, what you need to do is to equate the bases. X equals to 2. X equals to 2. That is your final answer. I hope you all understand this fundamental concept. In our next video, we will look at more advanced examples of exponential function. I will see you all in the next class.